Hello and welcome to another Solana tutorial. Today we're going to continue our journey learning Anchor in the Solana Development Course, Module 5, Lesson 3. We're going to talk about PDAs and accounts. Wow. Okay, because the thing is, Anchor does provide some additional functionality to make the handling of those accounts and PDAs simpler than if we were to use native Rust. But in order to be able to use that, you need to know how to, and that's what we're gonna learn today. So let's click there and go to lesson 3. Today we're gonna learn to use the seed and bump constraints. We're also gonna learn what a constraint is. We have used that already though, you know, this with the init and stuff. We're gonna use the init if needed constraint, and then the realloc and the close constraint. That's there now, right? That's there. Yeah, there it is. TLDR. Seeds and bump constraints are used to initialize and validate PDA accounts in Anchor. Then the init if needed constraint, we've already seen the init constraint, and now the init if needed just inits if it's needed. So if the account is not created yet, then it creates the account. However, that also opens you up to reinitialization attacks. So be careful when you use that constraint. Makes sense for some accounts, but in general, my recommendation would be to avoid it unless you really know what you're doing. The realloc constraint is used to reallocate space. Who would have thought that it's used for reallocation? What? Reallocation, if you were to pronounce it correctly. We reallocate more space on an existing account. Cool, let's do that. And then close, obviously you're gonna close the account, so it's gonna take the lamperts off, and then the account is gonna be deleted, because if it ain't got no rent, then validators are not gonna hold it in memory anymore. And back it goes to the system program, which opens you up to reinitialization. I cannot say, I've tried it 5 times now. To reinitialization. Reinitialization, which opens you up to reinitialization attacks. Hard thing to pronounce. Reinitialization. That's the word. Alright, overview. In this lesson, you'll learn how to work with PDAs, reallocate account, and close accounts in Anchor. Yes, Anchor, that's what we're doing here. Recall that Anchor separates instruction logic from account validation. Remember that in our great program from the last lessons, we had the instruction logic, which says what is happening when the instruction is called, and that is separate from the accounts. Here we define what types of accounts we have, and here we define which accounts we use in each instruction. And the validation, this is done here essentially through those constraints where it says this must be a signer, this must be the system program, this must be writable, this account must not exist yet so I can initialize it. All of this kind of validation is done here in the Anchor program. In addition to using constraints for account validation, so just to make that clear, those are the constraints that we're talking about. Right? In this example, we don't have many yet, but we're gonna get to know more of those constraints today. So just that you know the wording, constraints, this, macro, this, attribute macro even. And now the cool thing with those constraints is that they just add some additional boilerplate code that is, you know, usually always the same, and we just need to add one constraint and a bunch of code is written for us. If I wouldn't have this init here, then inside my logic, I would need to go through, invoke the system program, do a create account, execute that, do all the checks, and only then I can start with my actual logic. But in Anchor, I just write the init here and it does it automatically. It just requires to have also the constraint pair and space such that it knows how much space it needs to allocate and who's providing the lamperts for that account, right? But I don't need to calculate the rent or anything. That's all done automatically. And in this lesson, we will introduce seeds, bump, realloc, and close constraints. Yes. So we'll get to learn a few more constraints that we can use to work with PDAs and reallocate and close accounts. Cool. Probably most important of them is working with PDAs. So the seeds and bump constraint. recap, because we haven't said that enough times, a PDA is derived using some seeds, a bump, and the program ID. Here, for instance, when we find program address, we can put in some seeds and we provide the program ID, and then find program address will provide us the bump, which is actually also part of the seed. When we then sign, when we do a CPI, then we provide the bump as well. That's just a recap. In Anchor, we can do that pretty simply by just providing the seeds and bump constraint. Seeds is again just an array of seeds, bunch of bytes, wherever we get those from. And then that bump tells Anchor, please add a bump, specifically the canonical bump, so the highest possible bump that makes it a PDA. If we don't write anything, we can also say bump equals and then the value, then it will take that specific bump. But without anything else, it takes the canonical bump. Yeah, in most cases, we should use the canonical bump. The only real use case for providing a bump, in my opinion, is if we have stored it in the account, so we don't need to rederive all of the possible addresses. It's an efficiency thing. We can store the bump inside an account and then provide it the next time we derive it. So we only need to derive one address and not potentially more. That, in my opinion, is the only real use case why we would provide a bump here. And then during the account validation, Anchor will derive the PDA, so it will take those seeds and the bump. It will essentially do a find program address and then compare if the address it derived actually corresponds to the address of this account that is provided. And if not, it will throw you out with an error. You can access other fields from within the struct from constraints. You can specify seeds that are dependent on other accounts. Yes, can't only have like static stuff here, but we can also say sign a public key or whatever. We can even reference deserialized instruction data if we add the instruction attribute macro to the struct. Cool, that I also have never done. That's interesting. So here's an example. We have some static bytes and then user key as ref, so that's this public key, the public key of the signer, and then as ref, because in there we have yet another, reference of byte list. Just need to get used to that, providing it as a reference. And then that's also interesting because we have the instruction with instruction data string, so instruction data is of type string, then we can also use that down here and just reference this instruction data. And then obviously if that address from the PDA account does not match what is derived with those seeds and the canonical bump, then the validation will fail and the instruction. I'd say before we move on, we actually play around with that a bit, because we're not here for the theory, we're here for practice. So last time the data account could be any account that is being initialized. Checking my test, we did a new key pair and then just provided that. So today, let's make it a PDA. Essentially, we can leave everything the same. We just add constraints and say seeds equals, and then a list of seeds. And here we could be like data or any kind of whatever. And we can say each user should have exactly one data account. Then we would add something like user.key.as ref. Now, if we try to compile that, it will tell us that we can't have seeds without a bump. I'll demonstrate. There we go. Bump must be provided with seeds. It's not the first time I do this. By the way, if you read those Anchor messages, start with the top. Because if you read one of the lower ones, then method not found in, that's all resulting error messages from Anchor not being able to compile this part, and then this doesn't exist, and that leads to problems here, and that leads to problems here. So always read the first error message that comes, and in that case it's bump must be provided with seeds, and then fix that before you try and read the other errors. That's just something I learned from developing with Anchor. It really helps just to fix one error at a time. Right, so we have our list of seeds, and I just say bump, then it will also use the canonical bump. That should compile again then. Let's start our Solana test validator and then deploy. There we go, nice and quick on local. And now when we call this my instruction again with a new key pair, then we expect the account validation to throw us out. Anchor client. Let's see. There we go. Constraint seeds. A seed constraint was violated. Anchor error caused by account data account. Constraint seed. So that's pretty verbose. And when you see that, it should be pretty obvious what's happening. It even tells us which values it compares. This one versus this one. One of them was just a random key pair we put in. And the other one was the PDA that it derived. So, in order to make this work again, we need to provide the correct account. How do we get the correct account? Well, obviously, we need to derive the same PDA on client side as well. So, we can't have a new key pair here anymore. We just need the correct address. And since it's a PDA, we also don't need to provide it as a signer, obviously, because we can't be a signer. It's a PDA. The program will automatically sign, though that's fine. Anchor is smart enough to provide those PDA seeds then for the actual account initialization. Do you remember how we derive PDAs on client side? I give you 2 seconds to think about it, and then I'm gonna tell you. It's in the Web3, so the Solana Web3.js that is imported in the Coral Anchor. Here we should find public key, and the public key will have a find program address sync, so we don't need to await it. And then we just provide the seeds and the program ID. So our seeds were data, and that thing takes a buffer or a uint8 array. So let's say buffer from, that's my quickest way of doing this. That is number 1. And then we had a second seed, which was the user key as reference. So the user is wallet pub key. Let's use wallet pub key dot either to buffer, so we have it a buffer as well, or what also works is 2 bytes. Then it's a U8 array. That also works. It takes both of them and we can mix and match them. That's fine. And then we're still missing the program ID. Program ID. That's it. That thing will give us a public key and a number. So that will be the data account PDA and the bump that we will not use in this case, but the data account PDA we put here. And then we don't need to provide it as a signer. We don't need to sign for that anymore. It's now a PDA, so the program can sign for it. Save that, and now we should be able to actually call this instruction. Damn it, signature verification failed. Okay, we messed something up. You know what, let's log our PDA, a pro, and for R, we've seen this before. That's what it's comparing with. So the address should now be correct. But why do I get a signature verification failed? Okay, we have to write PDA. Damn, I thought I'd be good at this. Oh, could it be that I have the wrong IDLs up here? Yeah, and then you sit behind that for like... Yeah, that seems to have been the problem. Because it's still expected there to be a signer. It's still expected the data PDA. It was just a not up-to-date program, the IDL. Okay, so now it works. Great. Let's Solana confirm that. See what we did. So our program was called, the my instruction, and then the system program was invoked. That essentially does the system program create account, and then it says data account created. This thing now worked. We provided the correct seeds, and it created the data account as a PDA. Now let's also try the other thing where we try to get some instruction data into here. So let's say each user can create multiple data accounts and they, I don't know, provide a number. So just another, I don't know, byte or even U32. So how would we do this? We use this instruction data. And I'm pretty sure that that thing will then correspond to what I put in here, right? So let's do a PDA number, which is a U32. Why not have a lot? So we do PDA number, which is a U32. And then theoretically, I should be able to use my PDA number here. Now, how do I need to do that with a U32? If I want the U32 as a byte array, or really as a byte slice. Two little endian bytes. We'll get there eventually. So we now found an array. So that's the array, but we need the slice. Oh, what? Now it's unused? What the hell? Oh, okay, up there. Okay. Either the compiler is just not smart enough to get it that I'm using it here, or that thing does not actually correspond to the thing up there. We will see. We will see what's gonna happen. That's why we play with this. That's why we try those things out, because we do want to learn. So we would expect to have 4 more bytes here. While you deploy this, we're gonna fix that on client side as well. So first of all, our instruction now takes yet another number. Take 1, first PDA. Make it a variable, use it several times. Because here, we now need to add this PDA number as little endian. You know what, I'm gonna do this in 2 steps. I'm gonna write this number at position 0, and then I'm gonna provide this buffer, so those 4 bytes in here. And that stuff could now potentially already work. Let's see. Nope, different numbers. We provided the ER4 and it expected HXX. All right, so that's not working as I expected yet. Probably my assumption with this corresponds to this is still wrong. You can access the instructions arguments with the instruction attribute. You have to list them in the same order in the instruction. So you can omit all arguments after the last one you need. Aha! Okay, so I was correct, just I need to put them all. So I also need to put input number, which is U64, and then PDA number, and that I can ignore that here, and the PDA number I will then use. Let's see if that makes a difference. Looking good. Deploy this and check if that works now. Looking better. Still have the same ER as my data PDA, but now the on-chain program also has the correct one. Nice. Nice. So then it's probably not via the name, but just via the order. So I could be like foo and bar and then take the bar bytes. That would probably also work. No. Oh, yes. Different error though. 0x0 is of course already in use, which makes sense because we init and we don't init if needed, we just init. So to fix this, I'll just put the next number here. Then it should work again. Different PDA now, of course, because different set of seeds. Well, just 1 byte is different, but still it makes the whole PDA different. Well, 2 bytes might be different because the bump might also change. Cool. That works. Now there are so many things where we can continue. Like we said, we could say init if needed. Then it only reinitializes the account when it doesn't exist yet and still performs all the checks that it's of this type of account and that the seeds are correct and so on and so on and so on. I'm gonna rename this back now though, because it is nicer to have it, you know, correspond to those, because then you actually know where they come from. Makes the code easier to read. We could also have a look at the bump and providing a bump. I do want to do that at some point. What do we continue with? Or we just look what James has coming up for us. Okay, yeah, let's read through that. We have already done this, and let's go through the theory. We can combine the bump and seed constraint with the init constraint. Yes, we've already done that. That's nothing new. If we do the init, then we need to have the pay and the space and the system program such that it can do the create account instruction. For non-PDA accounts, Anchor defaults to setting the owner of the initialized account to the program currently in the instruction. When using the init in combination with seeds and bump, the owner must be the executing program, because the initialization of an account for the PDA requires the signature that only the executing program can provide. So obviously, since we don't sign, in our case, we don't sign for the data account anymore because the program can sign with its seeds. In other words, the signature verification for the initialization of the PDA would fail if the program ID used to derive the PDA did not match with the program ID of the executing program. Yeah, obviously, because then it would be a different PDA. But we can provide a different program ID as the derivation for the PDA. That we can do. It does set the owner automatically to my program per default anyway. And yeah, when I create it, I must be the owner. Otherwise, I cannot sign for it. That makes sense, yeah. Yeah, and then the 8 plus 8, we also know that from last time. That's with this 8-byte account discriminator, blah, 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 blah. Okay, now we get to an interesting topic. where I could probably learn something again, seed inference. To simplify client-side experience, we can turn on seed inference. Because for now, here, we're still doing this manually, right? But since Anchor through the IDL should know the seeds, we should be able to infer them. Adds additional information about PDA seeds in the IDL. For this example, the first is static and therefore known, and the second is known because it's in the transaction signer. So, if you use seed inference when building your program, as long as you're calling the program using Anchor, you don't need to explicitly derive and pass in the PDA. Anchor will do that for you. Turn on seed inference by setting seeds equals true in features in the Anchor toml. Let's try this. My Anchor toml in the features, seeds is false. How about seeds is true? And let's do a quick check on our IDL. That's what it looks like. Let's see what happens if I compile this thing with the seeds true. So let's open this again and see if something changed. Yes, we have a PDA here and it lists the seeds. Namely, first there's a const string data, then there's an account pubkey user, and then there's an argument U32 PDA number. Okay, I don't think it will get that PDA number and PDA number here. We don't do that anymore. Data account we just don't provide now. Let's see what happens then. Oh, do you not have a metadata field anymore? That's funny. If I use seeds, it doesn't store the program ID as a metadata field anymore for whatever reason. Okay, gonna quick fix this by hard coding my program ID in here. So, oh, that looks interesting already though. Allocate account address 5P9. Didn't we have that earlier? 5P9, I am amazed. It actually took that. Whoa. Okay, so if I provide PDA number 3, it should work now again. I'm seriously amazed that it actually took this thing to derive that account correctly. Wow. Yeah, that seems to actually work. I am impressed. Wow. Okay, cool. Now, on the one hand, I'm super impressed that that actually works because it makes the workflow so much nicer, right? You don't need to provide all the seeds and the correct order and provide them here. You can just leave that out and Anchor does it for you, which is great for efficiency. On the other hand, though, if you're just learning how all of that stuff works and you don't really understand accounts and everything yet, and that stuff is just omitted, then it's really hard to debug. It's really hard to find out if something is not working. Because if you just always expect stuff to work and then it suddenly doesn't, then you have no idea. So in a way, it's cool that we don't need to specify that. On the other hand, it's then not so obvious what actually happens. And that's one of the arguments for using Anchor and against using Anchor, that it just abstracts away a lot of stuff, which makes it easier to work with and yet makes it harder to learn and really understand what's happening behind the scenes. So it's a blessing and a curse at the same time. But very cool that you can do that. See, if you know how to do it otherwise, and then you're like, okay, I understand this now, and now let me specify this seeds equal true and let me just omit all of that thing because I don't want to write it all the time. That's perfect. That's what you want to do. You want to, not have to write all of that code every time. But you don't want to be dependent on those things that it actually works. You want to also be able to, in case something isn't working as expected, be able to provide your data account here manually again, which we can. We can overrule whatever. If we do specify it here, then obviously it's gonna take this one. So I could be like, if I were to use number 4, even if I use number 3 here, then it's still gonna overrule this with this PDA, and then that transaction is not gonna go through anymore, or even the simulation will fail because the PDA won't match. But the important thing is I can overrule it. Yeah, because I provided the data account and it now takes this one. If I have the 4 in here, then it should work again. There we go. Cool stuff. That's seed inference. Learn something new again. Next up, the instruction attribute macro. We have already been using this. Yeah, and we figured out how to actually use it. Let's see, what else does James have to say for that? Instruction data you provide in the list of arguments must match and be in the same order as the instruction arguments. Yes, I should have read that earlier. You can omit unused arguments at the end, but you must include all arguments up until the last one. That was my mistake earlier. And here he has an example. But we also figured that out by just looking at the anchor-lang docs. Proud of myself. Additionally, you will get an error if the list inputs are in the incorrect order. Will I though get an error? No, it will just use the input 2 as input 1 and input 1 as input 2. It's just gonna switch those two around. So I don't think I will get an error because we did test that we can name them foo and bar. So anyway, moving on to init if needed. Now we saw earlier that if the PDA already exists and we have the init here, then it will fail. If I try to initialize the number 4 again, then that's gonna fail because obviously that PDA already exists and therefore it can't create the account with the system program again, and it will just say 0x0, account already exists. Custom program error 0x0 from the system program, already in use. That's the error message. Not already exists, already in use. Cool. And Anchor provides an init if needed constraint, which initializes the account if it's not been initialized and doesn't initialize it again or try to initialize it again if it is already initialized. And this feature is gated behind a feature flag to make sure you are intentionally using it. For security reasons, it's smart to avoid having one instruction branch into multiple logic parts. As the name suggests, init if needed executes one of 2 possible code paths depending on the state of the account in question. Yeah, what James says is usually you know exactly what's supposed to happen, so either you initialize it or the account should exist already, and using this flag just opens you up to vulnerabilities. When you use it, you need to make sure to properly protect your program against reinitialization attacks. Reinitialization. Yeah. You need to include checks in your code that check that the initialized account cannot be reset to its initial settings after the first time it was initialized. Because obviously an attacker can try to take advantage of that flag and essentially try and close the account again, even though he used it already, and then do the instruction again with that init if needed, which is then gonna be initialized again, even though it shouldn't have been, or something like that. If we are sure we are okay with that init if needed and it makes sense to use it there, then we can enable it in the cargo toml, essentially by including our anchor lang differently in the cargo toml here. Dependencies, anchor lang is this version, and instead we say anchor lang is this version with the feature init if needed. So we remove that line and we put that line here. Then we can use this flag. Actually, before I save that, just so you see the error message that occurs if you try and build it or if you try to use the init if needed, but you're not allowed to. It's pretty verbose, so you should figure it out. There, you get a init if needed. Init if needed requires that anchor lang to be imported with the init if needed cargo feature. So pretty verbose, it's pretty obvious what you need to do, and it even tells you carefully read the docs before using this feature to make sure you protect yourself against reinitialization attacks. Right, so let's say we read all the docs, we are sure that in this case no reinitialization attack is possible, or because we really don't care about our data accounts, like it's just 2 random numbers that we don't really need to protect in any way. We are okay with using the init if needed. We've saved the cargo toml and we build again. Apparently now it needs to rebuild anchor. While we wait, the example below demonstrates in a new associated token account. So with associated token accounts, that makes perfect sense because an associated token account, we don't really care about the reinitialization of that. If somebody closes their associated token account and we open it again, no worries, that's fine. I mean, that's how it should be done even, right? If you don't need the token account anymore, you can just close it and then you open the same one again. No problems with that. So for an associated token account, that makes perfect sense. And we don't want to have to initialize the account if it's not already initialized. We don't want to worry about that, right? we can just tell Anchor, hey, if that one doesn't exist, just create it, right? And it goes like this. We say init if needed. We specify who provides the lamperts. And then we also specify the mint and the authority. And then Anchor does that automatically. Here we already see we are working with token account and mint. That is in the Anchor SPL crate. For that to work, we actually need to import some more stuff. And I have decided I'm gonna make a separate video on just working with tokens in Anchor, because we don't really talk much about it here in this tutorial. And there are quite a few pitfalls. So I'm gonna save all of those things and what all of this means for another video, because I think James also doesn't really go into depth here. The whole point of this is Anchor will check if that token account, this one, already exists, and it will initialize it if not. If it does exist, then the instruction will continue without the initialization. Easy as that. And just with the normal init constraint, we can also combine it with the seeds and bump if the account is a PD. So maybe let's have a look at that, because that's what we're doing here. Can have the init if needed in combination with the seeds. There we go. It finally built and doesn't give us the warning or the error anymore. So let's deploy this and then try the same thing with the same PDA number as before. That thing that was failing before. Let's see if it goes through now. Yep, it does. There we go. Let's have a look at it as well. And we see in the logs, there is no more call to the system program. It's just my instruction and data account created. And we just overwrite the data in here. And data account created is wrong in this case now, because it was not newly created. It was just reused. But we can create a new one as well. If we were to provide number 6 here, for instance, then it's gonna create that account and we don't need to provide anything different. So it's really convenient for us, and depending on what kind of account it is, it can also be convenient for an attacker. So really think hard about if you want to use that init if needed constraint. Because in most cases you want to split it. In most cases you want to split the initialization, so have one instruction for initialization and one instruction for writing new data or updating data. But yeah, cool. Also, that has worked. And here, if we check that out, this time the system program was called again to create that account. There we go. Easy as that. Noise, noise, noise. Actually, before we get to that realloc, I want to show you something else that I think is quite good to know, especially if you're building like bigger programs in Anchor. I've mentioned it earlier, but you can define the bump. If you don't specify anything here and just say bump, it takes a canonical bump. But you can say, please take this byte for whatever reason, right? I could do that, which in this case doesn't really make sense because it will just break it. Bump target should not be provided with init. Okay. In this case, it doesn't make sense because we initialize this account, so we can't provide it when we initialize, because here Anchor is like, nope, we only use the canonical bump. F off, get out. It will always find program address if we init it. But we can provide a bump when we use a data account. For instance, here in our sum accounts, we could add functionality to implicitly let only a user sum its own data accounts. Now we could do something like this. We add the user as a signer, so they must sign because they use their accounts. And then we guarantee that the data accounts belong to them by providing this account macro with the same seeds and the user. And then we would need to again have them, the input variables. Yes, I made it a bit complicated for us now. PDA1, and that's the PDA2 number. So here we just provide the seeds, and the user key is one part of the seeds. So this will now guarantee that the data accounts actually belong to the user, and the user can only sum up their own data accounts without even having to save the authority inside the user data account. We do that now just via the PDA derivation, because as soon as there's another user, PDA will be different. Cool. Now that didn't play with the bump yet, but let's compile that and make it work. Yeah, and to get a way of, say, I'm not actually using those, and I don't really need to name them differently down here. It's fine. There we go. Got rid of the warnings. Cool. Then we deploy this. Meanwhile, build our client to make a sum. So last time when we did this, just provided those. The MySum now needs two numbers. So we can say take my account number 1 and take my account number 4. And then the data accounts, it should be able to automatically derive them because we have the seeds on, right? In our IDL. For all of the data accounts, we find the seeds now. We'll see if it manages that. So we don't actually provide the data accounts, we just provide 1 and 4 here. And the thing that we do need to provide is the user though. So that's again our wallet pub key. And that's it. And just by providing the 1 and 4 here, it should know which PDAs to use. Let's see if the sum also works. This is so fun. So little code. It all hides in the Anchor IDL. Oop, got an error. Program could not deserialize the given instruction. Well, then let's provide the data accounts. As soon as I use a number twice, I make a variable for it. And if I use code twice, then I'm gonna make a function for it. And now we can provide them as data account number 1, PDA1, data account 2, PDA2. Let's see if we can build an instruction like this. Still the same error, so that was not the problem at all. Instruction did not deserialize. Oh. There we go, that's already looking better. Okay. I mean, from that error, finding that mistake, not obvious, non-trivial, but hey, it works. Cool stuff, cool stuff. Would it also work if I don't provide those two? Yes, it would. Anchor is amazing. Wow. Okay, let's check that out. The sum is 6. What did I write into my accounts today? 3. I was always writing in the 3 in there. Okay, that makes sense. 3 and 3 is 6. Now we could even use the first instruction to change one of the numbers. Point is, this works, and it works quite well. However, every time when we check the seeds for this PDA, we need to do a find program address, which for 2 accounts, okay, still easy, but let's imagine you had like 10 PDAs where you always want to validate the address. You always need to find program accounts. And the find program accounts also has a loop and has to derive it several times depending on how far the bump is. So, good practice is to just remember the bump. I mean, it's just 1 byte. Yes, you have to pay 1 byte more rent, but therefore you save on compute because if you provide the bump, then you don't need to find program address, but just get program address or create the one where it doesn't loop, but just does it once. And then if it's not the right one, then it says, no, piss off. For instance, we haven't stored our bumps now, but if I were to say this thing needs to have bump 255, that still compiles. And now I restrained my allowed data accounts just to the ones where the bump happens to be 255. Let's check if the account 1 has bump 255. Yes, it does. Both of them actually have 255. Okay. But what if I pick another one? Number 3 and number, I don't know, 5. Number 3 also has 255, but number 5 has 253. So if I put number 5 here and whatever other one back there, the other one I don't check anyway, now it will fail because the bump doesn't give us the right address anymore. And this one will fail now. It's great when something doesn't fail that I expect to fail, because that means my assumptions are wrong, and that means I can learn something. We have the 5353 as the bump. We have not deployed the program, that was the issue. Okay, well, sure. Yep, classic, we have not deployed this. But with the newly deployed program now, it should definitely not go through. Yeah, that was a stupid mistake. I'm making stupid mistakes. That's just normal, part of coding life. And there we go. Okay, fine. That's what I expect to see. A seed constraint was violated again. Yeah. And the compared values are undefined this time because it can't compile the other one. Can't find the program address because it's not a valid program address, so it doesn't even compare. So this is the error. It's not more verbose than that. It's just a seeds constraint because the bump is part of the seeds. So it's still a seeds constraint that's violated. Now, obviously, it doesn't really make much sense to have a hard-coded bump here. I just did that because I don't know what the bump is. I have like a 50% chance of it being 255. But in reality, it would make sense to get that value from somewhere, the correct value, like the bump I would expect. Because when we do this, here we calculate the bump anyway. So why not remember the bump inside our data account? Let's do that. Inside our data account, gonna make another U8 for the bump. And then here we add a 1. And then up here, we store the bump. Now, how do we get the bump? Well, in the context, it has bumps. Bump seeds found during the constraint validation. So when doing this, it finds the bump and then it stores it. So we can use it up here in bumps dot get, and then the name of our bump, or of our account, sorry. Name of our account was data account. And since that is any random string that I can put in here, it could be that there is no bump for that. Then obviously it won't give us anything. So if I unwrap, it gives me the actual bump out of this result. Otherwise the error will be just thrown, raised. And that's essentially how we get the bump into our data field for the bump. And then we can access this data field down here. We can say here, from my data account 1, give me the bump. And also here, data account 2, give me the bump. That has the advantage that I don't need to find the right bump anymore, which makes this account verification more efficient and therefore uses less compute, and therefore we can do more other stuff in our instruction without requesting more compute. Or we don't have to request more compute, right? So needing less compute is a good thing. And in my world, it's worth storing the bump and paying that 1 byte more in rent. You could theoretically also do the same thing on client side, but on client side, I don't really care that much about compute and do the find program address. I could also here provide the right bump, but then I need to first query what the bump actually is, and that I wouldn't do. I would just calculate it. But chain, storing it and reusing it, I think it's a good strategy. That's why I wanted to tell you. Now let's actually see if that works. We have a reference and we want a U8. Of course, we need to borrow. My bad. Boom. Rust. There we go. And the program compiles. This time we deploy it. And since we use the init if needed, we can just call the my instruction more often because, oh shit, but I need to realloc for that to work. Nah. Okay, so first, it's not gonna work with those accounts 5 and 1 because they haven't stored the bump yet. We would need to first create 2 new ones. I don't know, let's do 8. Let's create ourselves 2 new ones that have then actually their bump stored in the account. And if we then use 8 and 9 for our sum, and there we go. Even though one has 253 and one has 255, the transaction goes through because the correct bumps are provided. Now, obviously to the outside, it looks like the exact same thing, but this stuff is more efficient. Let's look at that. Sum is 6 again, and essentially it used those 2 accounts, this one and this one, so the 86 and the CC. Let's check them out. Here it had the bump 255 stored. The other account, this one, has the 254 stored, so it should be FE. There you go, FE. Nice. We store the bumps inside the account and we use that to always have our canonical bump, but not having to recalculate it every time. That's quite neat. Cool. Now, if we were to use our other accounts, you know, the previous ones that looked like this, that didn't have the bump, and we want to provide the bump and 1 more byte of storage, what do we need to do? Yes, we need to realloc. So let's have a look at how that works. So, realloc. The realloc constraint provides a simple way to realloc space for existing accounts. The realloc constraint must be used in combination with the following constraints. Mutable, well, obviously, if we can't write to that account, then we can't realloc anything. Realloc pair, that's the account to subtract the lamparts from or add the lamparts to, depending on whether we add or remove space. And realloc 0 is a boolean to specify if the new memory should be 0 initialized. 0 initialization, oh, I know about this, because here's the thing. If we realloc and we don't 0 initialize and then we don't write anything in there, we can't have random data in there anyway, because there is no random on the validators, because each validator must have the same result. The 0 initialization is only then important if we realloc it to a smaller amount that then the remaining data is still there. There was an attack. I did a capture the flag where there was an attack like this, where they didn't set the realloc 0 and then you could overwrite some, but only in an old version. Actually, I have a video about that. I'll link it here. So yeah, I don't want to go into too much detail. It basically just says whether or not it should write zeros there. And as with init, you must provide the system program, because obviously only the system program can do the account reallocation. Here we have an example. We say realloc to a given instruction data, and then the realloc pair and realloc 0. We can say false because we overwrite the data then anyway. So yeah. Now my question is, can we have a realloc in combination with an init if needed? Probably not. And I want to try. What if I just add those constraints? Say this is the space I want. Reallocate if you don't initialize. And the payer is the user. That's fine. And the realloc 0 is false. That's also fine. Can I do that? Probably not. And we will not know unless we try. Mute must be provided before realloc. And then it will tell me mute cannot be used at the same time as init if needed. What you bet that that's the next error? Yeah, mute cannot be provided with init. Damn you! Okay, fine. You know what? Then we just don't allow new accounts anymore. We won't. Now only use accounts that already exist. I mean, normally I would make a second instruction now, but I'm too lazy. And now it should build again. Here we go. It will realloc to this size, which means that we can now bring our old accounts like the PDA 1 to the same standard. Let me quickly comment that out. That in, and we use PDA number 1. Oh yeah, and don't forget to deploy. Run this again. Damn. BBB this time. What the hell? Failed to deserialize account. Aha. Because I have a bump in here and that account doesn't have the bump yet. So it failed to deserialize that account. But that's why I want to update it like this. You shouldn't deserialize my account. Just ignore it and put it in here and then it will be fine. We're gonna reallocate it anyway. I mean, it would be good to know how we could fix that, because that could happen that you want to add something to your account. Okay, let me try something. What if we don't have the bump here? We also don't yet store the bump here. We just reallocate to 1 more byte. Now it should serialize again. Now it's just a normal old account that we had. Cool, so that has worked. That's not as nice as in the Explorer, but we see that we paid a little bit and this account was topped up by just a little bit here from 101 to 102 because we have 1 byte more, so it needs more rent. Maybe let's also have a look at the account itself. We have an additional byte 00, even though we set 0 init that to false, obviously it's gonna still be 00 because deterministic. And now that we've updated the size of it, can I now be like, oh, this suddenly has a bump now. The last byte in here is a bump. And if you do that, then please write this. And now do the same thing again. Nice, so we just need to do it in 2 steps. And if I now check out the account again, damn it, I would have expected 255 in there. Ah, did I not build and deploy? Ah, classic, forgetting to build and deploy because I'm getting impatient here. But now, nice. And if we now have a look at the account again, now it also saved the bump in here, which means we can now use this number 1 and the number 8 that we created anew to build a sum. Actually, I for once want something else than a 6. I want a 69, of course. So I'm gonna change the data to 66 first, and then I'm gonna build the sum. Point is, I can now use the account number 1 as well for my sum, because we have the bump stored in there, because we managed to realloc. So that's the update, and there we have the sum. So let's Solana confirm, and we see that the sum is 69 now. And it used the correct bumps. Nice, 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 nice. The ER and the CC. Cool stuff. Cool. That's the realloc. Now there's only one more thing that I want to go through, and that's the closing. That's to close. We talk about closing accounts as well. Just another constraint. The close constraints provide a simple and secure way to close an existing account. Well, it does what it says, closes an account. Can't be that difficult, is not that difficult. Let's see. It marks the account as closed at the end of the instruction's execution by setting the discriminator to the closed account discriminator and sends its lamperts to a specified account. Okay, so that's interesting. There is a closed account discriminator. Basically, Anchor writes that there such that if the account is used again in an instruction in the same transaction, you can still use the account. That's the thing. You can still use the account in the same transaction, even though it has been closed already. And then you could theoretically pump up the sol again, so send some lamperts there. Then it's not actually getting closed, but Anchor has this security feature with a close account discriminator, you know, the first 8 bytes, that it then knows, oh, even though there is data there, it's not really my account anymore, or that I expect it because the discriminator is different. That's what I imagine. I just read about this and my imagination is that's what it's for. Setting the discriminator to a special variant makes account revival attacks impossible. I think that's exactly what I was talking about. Where a subsequent instruction adds the rent exemption level. Yeah. That's what I was talking about. If someone tries to reinitialize the account, the reinitialization will fail the discriminator check and be considered invalid by the program. Yeah. So even though the account lives on, my program will then not accept it anymore because it's not of that type anymore that I specified. We could have a look at such a revival attack, and I don't want to. But let's first look at it the normal way. The example below uses the close constraint to close the data account and sends the lampert back to the receiver. So it's pretty simple. Obviously, it needs to be mutable. That's quite obvious because we need to be able to, write to the account if we want to first change the lamperts and secondly, essentially erase it. And then close just takes the where should the lamperts go. So yeah, let's make a separate close instruction because that makes sense to have it a separate instruction. Close. I can, however, have the seeds at the same time, right? I have mutable, close, give the funds back to the user, and I keep my seeds. And even the bump, I can specify again from my data account bump. So data account, the user must be mutable because we add lamperts to him. And then the system program we need because obviously, do we need the system program? I don't think so. I don't think we need the system program actually. Let's try without. And then obviously we need the instruction, my close, PDA number for which one to close, and data account closed. Essentially, we don't do anything because even the logic is done by this constraint now. So I just say data account closed. Okay, let's compile this. Oh, I don't need that context. Yeah, whatever. And then we deploy and then just do methods. It's already here, my close, and it needs the PDA number. So which one do we close? Let's close number 8. Accounts, what do I need to provide here? The data account, it will be able to defer because seed inference. I just need to provide the user, which is my wallet pub key. That's all. And then I RPC this. Such little code. Let's see if that works. Anchor can hide so much functionality. It's fun and complicated if you've never, imagine you're looking at my Anchor program and to try to understand what's happening when you're a newcomer. No chance. So let's look at it. Data account closed. That's it. And the account that was closed is this one. It went to 0 lamperts and I got those lamperts back. Simple. And if we now look at that account, the CC that was closed, then account not found because it's been closed. It's not there anymore. I would really like to see what that thing is. Maybe it's all ones or all zeros or something. Probably all ones. If I were to choose it, I would choose all ones, because all zeros would mean it's not initialized, and all ones would be it's closed. And it is all ones. Yeah, in the source code we can see that it is all ones. I would have loved to see it on the account though. So far, I just don't manage to do a reinitialization attack. Anyway, I will not go through the demo. You can, as a challenge for yourself, go through that. James has some tasks for the movie review program in Anchor. And I would argue we practiced this enough on our first little program here, and I don't really see the value of doing that by myself. That would just be a typing exercise for me, so I'm not gonna do that. Also, the challenge, if you want to do it with the student intro program, you can. I would consider this lesson done. We have learned a lot here, and I would say it's complete. Yeah. Oh, man. We learned so many cool things, though. Like the init if needed, the seeds, the closing. Because Anchor is pretty cool if you know how to use it. And the whole thing that it derives the accounts itself because we use the feature. Pretty nice. I hope that this video was helpful for you. Leave me a like if that was the case. Subscribe and watch those other videos about the development course or other interesting stuff that's happening in the Solana developer ecosystem. And then I will see you in the next video where we will talk about CPIs and errors in Anchor. Yes. Until then, bye-bye.